Good morning, everyone. This is the first Nmrg session of the week. So welcome, everyone. I'm Laurent Chavaglia, and here is Jérôme François from INRIA, the new co-chair of Nmrg, first time live. So we have a very tight agenda today, so we will start right away. And I will ask the presenters to really stick to the time. And if you are willing to make comments, please be to the point and try to be short. So goals of the IETF. The IETF conducts research. It is not a standards development organization. This is a sort of message reminder that we are putting in research groups to highlight the difference between IETF and IETF. Nevertheless, IETF follows IETF policies, and so this is the note well reminder on the IETF policies in effect on various topics such as patents or code of conduct. So please be aware of those policies and comply to them. So this we can skip. We already have thanks to Dan for being our meet co-scribe, and Jérôme and myself will take care of the minutes. If anyone is willing also to help us with the minutes, we have the HIFA pad here, and you can directly put it your notes. Blue sheets, so please circulate the blue sheets. If you are the last in the row, please bring it back so that we can also circulate them during the meeting. Quick glance on what we will have this week. So we're already close to the end of the meeting, but today we have our first session, which will be concentrated on intent-based networking. And tomorrow we have also a second session with two main topics, discuss a bit of the rechartering process and a synthesis of the different activity on network artificial intelligence. As I said, we have two full agendas, so please stick to your time and be concise in your comments. This is the agenda of the first session. So we are currently in the introduction. After that, we will make a quick report on the interim meeting in October in Roma that was focusing on practical aspect of IBN. Then we have a couple of technical presentation on the active internet draft for the group, intent classification from Olga that will be removed, and Alex, which will make an update on the IBN concept draft. And then the final slot of today, we have a set of technical presentations. I will not go through that, but this is covering a different set of topics and also new proposals. Anybody has something to add or change to the agenda? It's good for you? So a bit of overview of the status of the research group. There is an ongoing revision of the charter. We have sent email yesterday to the group and also to the IETF chair. We think we have a stable version of the revision, but it's welcome. We welcome your comments and reviews on this new charter. So you have the link to the charter, and on the mailing list, you have also links to the comparison between the document and the first version of the charter. So the idea is to have a kind of umbrella text covering, describing quickly the main research direction of the group and the relationship, and also to highlight a more detailed work plan on the intent-based topic, which is the main topic the working group, the research group is working on so far. We aim to approve the new charter by the end of this year. And of course, your comments and feedback are most welcome. We will have a bit more time to go through the rechartering tomorrow. But in the meantime, you can have a look at it and send us your comments. We have also sent to the group and discussed about a proposal for procedure of adopting research group documents. There is no formal process in the IETF for the research group how to approve to move individual documents to research group documents. This is on purpose. We are not a working group, so this is not a formal process. But still, we wanted to have to document a clear process so that everyone is willing to move towards research group documents can know a bit the criteria we will use as the research group chair to validate or not the progress towards research group documents. So work as usual, zero precondition. So update your individual draft, take into account the comments, discuss the issues on the mailing list. So keep updating your document. This is a good sign that this document is alive. Then for the adoption, first check that you validate a set of criteria. Do you have a precise scope of the draft? It needs to be clear and hopefully will not change once the research group document is adopted. We are doing research, we are looking for good scientific quality, and we expect a good impact also in the community. So it needs to be rigorous, scientific based. And the current content must be mature enough. We are not looking for finalized document, but still we need to have not mature enough technical content in the document. We need to also have indication how you plan to continue the effort. The content of the draft, evolution of the document must be already planned. If you can have also an indication of work plan or milestone, this is even better. And to know a bit more who will work on the draft. So this is, we hope, commitment from the authors, but also in the group, if you have indication of people willing to review or people willing to join the effort, this is also important indicators to know that this is of importance to the research group and that it will be progressed. I need to speed it. Okay. And then request for adoption. So you can ask it on the meeting, during the meeting on the mailing list, and also the research group chair. We also forward the call for adoption on the mailing list to let anyone a chance to comment. An overview of a few projects that we have inside the research group. So IBN Resource Hub project. This is an idea to create a place, website, GitHub, whatever the form we have not set yet, which will be open to all and to a user-friendly interface to collect external resources on internet-based networking technologies, articles, standards, documentation on product, whatever. It could be useful for the community to have in one place. We are also working on a participation to hackathon. We have a target a bit in the future, July next year in Madrid. We would like to grow the IBN activity on practical aspects with development of tools, demonstration of proof of concepts. So the idea is to also work theoretically in the research group, but also make some implementations. And we want to leverage the European allocation also to invite different teams, European or worldwide teams, but also EU-funded projects. And so we have made first steps at this hackathon to connect, and you will hear more in the coming weeks. We have also the Network AI Challenge project. Jérôme will make a synthesis of that tomorrow. There are different aspects we are working on: definition of the use cases, identification of data sets or evaluation platforms, and publication aspect of the challenge. Meeting plans for next year. So this is tentative. There is a lot of things that are still open, but we plan to meet in the different IETF meetings. We also plan to have a few interim meetings face-to-face, collocated, for instance, with IM NOMS 2020 in Budapest, as we used to do. We are also looking to have an interim either in Tokyo with the IPOP conference or in Brazil with SBRC conference. This is still being discussed with the local organizations. And we have also monthly virtual meetings. So we will see if we need one in December, but at least the next one will be surely in mid-January. So that was it for the research group status. Any question on the research group before I move to the report? If not, okay. So this is a quick report on the interim meeting we had in October in Roma, collocated with the Network of Future Conference. The focus of this interim meeting was practical aspects of internet-based networking. We have invited for a joint demo session with the conference, and we received 4 papers, 3 demos, and invited talk to make demonstration on IBM technologies and also discuss. We have 2 days of sessions, discuss a bit more the practical aspects of internet-based networking technology. We wrote a report of this event, so this is currently available on the data tracker. You have the link here, but this is will also be published as part of the proceedings of the conference. So you have you can find it on IEEE Explore, and also the demo papers were part of the conference, and they will be published with the proceedings. We thought this was a very useful and kind of different meeting that we have here, or that we used to have with the virtual meeting or other interim. We learned a lot from the implementations. They had to make decisions on the format of intent, the infrastructure to support it, the transformation of intent. So it was really useful to compare different choices and also to confront theory and practice, because in the group we had several drafts, but this is a theoretical design, and then in the implementation This was more to report on implementation choices. And it was also helpful to generate further ideas for instance, the hackathon project and collaboration between different teams working on those tools. Again, the idea is not to go into a full report. If you want to read a bit more, there is a 4-6 pages report available. You can also come to us. It's very synthetic, very quick to read. You have all the information on the demos, the links, and all the materials are also available on the interim meeting page. We have also identified a few further directions out of this meeting. So to create a code repository for the tools and the demos, and with installation guides and installation and user guides. This is still in our to-do list. We have also defined a IBM tool datasheets to describe the different experiments. So the participants of the meeting committed to describe their tools using this datasheet. We think it will be useful also to have this datasheet so that people can know a bit more what are the tools doing, and also provide a bit of documentation. We're also proposing to have a kind of mapping table. Mapping table is to make the bridge with the draft on intent classification. So in the demo, they have made choices of the environment, the intent format. So the idea was to use the mapping table to see where it fits in the classification. So maintenance and updates of the overall IBM tool view. So this is this is the tool view. So we have a draft intent lifecycle, and we try to map the component of the different demos to the different stages of the lifecycle, the different functions. So this was a work in progress during the meeting, and we want to keep updating this table and use it to understand if we are missing something in the lifecycle, if some functionality are well designed, or we need to split them, etc. So this is to use this as a tool to understand a bit more the entire lifecycle. We have follow-up interactions. There have been point-to-point between the teams saying, okay, what you have done can also be used in my demo. We can interconnect. So we expect that there will be more exchange between the different teams, and to have also follow-up meetings on practical aspects. And as I said, we are developing a project to participate in the hackathon in IETF 108 in Madrid next year. And we are working with Jerome to make a kind of presentation of what we aim to do there and connect with a set of teams. So that's it for the report. Some questions on this meeting and follow-ups? So if not, we will switch to the next presentation. Olga, the floor is yours. Olga, this is your turn to talk. Can you please tell if you can hear us? Olga, try to talk, please. Okay, Olga, I hope you can hear us. So the instruction is to please click on the mic icon, which is next to your name, top left corner. You need to unmute in mid-echo. Olga, can you try to talk, please?
Hello, can you hear me now?
Yeah, now it's good.
Oh, I'm really sorry. Like I didn't have the list of names. I only had the video because of the format of the screen. Sorry for this. I'm really sorry I was not able to join you in Singapore. So I'll try to be quick because I took few minutes of your time. So what I'll present today is the version 2 of our intent classification draft. And here is the list of contributors through version 00, 01, and 02. So next slide. For those of you who, for those of you who are not familiar with this draft, our goal was to achieve agreed terminology related to intents and to propose a classification approach for different types of intents for our group, but also to guide other groups in IETF, and even other standards. So focus of this draft is the user intents and to define and classify those intents. The scope was relevant for any system or node that expects interaction with human user in the intent-driven networks. And that human user, beside being operator, administrator, end user, customer, is also the application developer who is building applications on top of the intent interface. And intent-driven approach is applicable to both autonomic networks and networks, the new future networks with machine learning and AI, as well as the traditional networks where intent could be used on top of the existing controllers and management systems, etc. Our classification approach was based on different solutions, users, their purpose, life cycle management requirements, scope in the network scope, network function scope, etc., and also abstraction for the intents, whether they are technical with technical feedback or not. So, and we have different intent examples. Next slide, please. So these are the milestones for our draft. As you can see, version 01, and we are here now in November 2019. We are proposing version 2 to be adapted, and then we are looking at potentially at March 2020 for the version 3, which would include all the comments and outstanding things. So the following is the list of comments received, and we addressed all of these comments. We added some use case references. Some of the comments would be addressed by different draft that we started for the intent framework, because this draft is only about intent classification. Some of the comments, one of the comments that Diego had was more related to the framework, so therefore there is a new draft intent framework being started on. There was also a good suggestion from Lauren about the classification table, and as the table he discussed when presenting the status from the Rome meeting, and that is we added that table as Excel, but then also to the draft so that everyone can use it and that POCs can use it for their classification. So we would appreciate any comments for any of the parts, but especially for classification table. There were also comments from Ericsson about the they proposed not to use the term granularity and instead to use potentially abstraction. So we also addressed this issue, added abstraction section, but also used the input from China Telecom, where they were suggesting to talk about technical feedback or not. So we now have a proposal to use for classification abstraction, technical with technical feedback or non-technical without technical feedback. There were other few comments that we are going to address or been addressing at the moment. Next page. So this shows the table of contents for version 1 and what parts have been changed, mostly main updates in this version. So you can see that section for those who want to review only the change sections, who already reviewed the previous version. It's section 3.2 intent solutions and intent users, in section 4.2, which used to be granularity, and now it's called feedback. Section 5 has been added, and it is an intent classification table example with a table for carriers, table for data center solution, and table for enterprise solutions. And section 5 has been moved to 6, and we added some clarifications in section 6, which has been moved to section 7. Next slide, please. So the use cases and some references were added. Example for carrier network scenario, use case where the user wants to watch high definition video and the system then has to map their intent into the technical requirements for the network. For data center network scenarios, the use case was about intent such as load balancing, where the administrator wants to restrict the maximum load on the node container below 50% and the maximum load on any link below 70%. For enterprise network scenarios, when hosting a video conference, the remote access is required, and the network operator has an intent that for any user of the application, that everything has to be synchronized within 50 milliseconds, the video, in order to reach the destination viewer of each conversation session. So these are the use cases, and China Telecom helped to bring these use cases. Next slide. So the feedback section was added, and we created two categories here, ordinary users. So that would mean customers and users, or non-technical users, or application developers. You know, some applications where they don't care about how intent is executed really. What they're interested in is the feedback in terms of success or failure of that intent. Other type of the users is more technical users, and for them, that intent may be more technical, but their feedback may also be technical, because what they're interested in is they're also interested in how intent is realized on the network. So they're interested in network resources, paths, some resource information. So in that case, it would be a technical intent with technical feedback. Next slide, please. So also there was some request to add some more information about how AI technology, what role it can play in the intent-driven networks, intent-based networks. So we added some explanation into section 6. Originally, section 6 was talking about that AI/ML-driven system would be driven by intent, by the goal intent or policy intent. Goal intent would present the target state, and policy intent would present some guidelines in how to realize and deliver that goal intent. But there are additional explanations added, and maybe I won't go through all of them here, how AI may be used for security, translation, or closed loop self-optimization, self-correction. So you can maybe look at that chapter section and do your comments. The next slide. It's also additional explanation in that section. So these are some examples of how ML and AI could be used, and some example of how clustering algorithms could be used. Next slide. So here is the just example of one of the tables, and this is really where it would be great for all POCs from our previous meetings to maybe position themselves. And of course, any comments, we consider this table. We did take a lot of comments and we kind of spent a lot of time working on it. But of course, we are hoping that in version 3 of this document, there would be more reviewers and contributors which would bring value to this table. This is example of different type intents. This is for carrier solution only, where we identified different intent types based on the solution. We did some descriptions, and we also proposed initial categories which could be based by the intent scope or a network scope or abstraction, and also life cycle, because we believe there are two types of intents: those that are kind of goal intents, that are persistent one, that are focused on the full life cycle, like a target network service, and there are those transient intents, like short-living intents, which are some actions that intent users are doing. So that there are two types of intents. So please see these tables and tell us if you have any comments on those. Next slide. So the conclusions here: our current version addressed most of comments received online and offline. There are some comments that we received also in last few days, and we would be addressing them in the future. But we do believe that because of major updates and as well of addition of classification table, it would be good. We want to ask for adoption of version 2 as a draft, so that this draft could be reviewed from now on by the community. These are some of the next steps, like start using collaboration tool, and we put it currently on the Google Drive as a version, but we would communicate with all contributors and maybe get their preferences. We want to also add a section briefly describing intent work status in other SDOs, and we also want to work with community to deliver a unified intent definition that encompasses all intent types for all solutions and intent users. So these are some of the next steps, and also to address all additional comments and update the document based on the response and feedback from the community. We also have few additional contributors that show the interest, potential contributors that show the interest, so we may add more contributors to the list. So I would like I would ask for adoption as a draft. Thank you.
Thank you, Olga. So, comment from Christian, from people in the room? No? Okay. So maybe one question from my side, so Jérôme François, not as chair of the group. You were mentioning in the modification you have done, I think you were mentioning this classification using the feedback from the intent realization. And when reading the text, for me, it seems that it's exclusive classification, that an intent will provide feedback to the user or not, the realization of the intent. But I suppose that, for example, an intent expressed by hand user can actually does not need to provide feedback to the user itself, because it does not need to know the technical realization of the intent. But at the same time, the administrator of the system may want to have the feedback to know how the user intent has been realized. So I think basically the feedback that you were expressing there may not be only directed to who has expressed the intent.
Yeah, you are right. Yeah, for the customer intents and application intents, administrator and operator would always be able to see the status of the network and to check the network. But this is specifically mentioned if the administrator and operator is the intent user. So in that case, their intent would be more technical than the intent, even if their intent does the same thing as the intent of the customer. Let's say network service. So if the customer requests a network service, it may be non-technical. If the administrator requests, it could be more technical, but also the feedback it receives for that could include some realization information. And if it's another user, non-technical intent user, then that feedback wouldn't contain that information. So we are talking about both intent being technical or non-technical, but also response to that intent being non-technical or technical. But I agree, like the administrator and operator would also have visibility into intents of all other users. Yeah.
So this is Alex Clem. I do have one question also from a cursory read, but perhaps you can explain this here. So looking at all the tables that you were adding with the classification, one thing that is not quite clear to me is how you would actually use this. Basically, I mean, it's very refined. You can basically give in great granularity, tag basically the different intents that are being defined, but how would that be expected to be used? I mean, basically, are there different I don't know, are there different methods going to be associated with different types of intents, or is this a way to basically catalog which intents belong together, or can you perhaps comment a little bit on the usage of those tables?
Yeah. Thanks for the question. The comment, the suggestion, it really came from the chairs, from Laurent, and I think that was a very good comment for the previous revision, because the original revision was mostly text, and it was talking about, we can have these type of intents and those type of intents. And then during the last meeting, we had POCs and demos. So we were saying it would be great if we can classify those different POCs and demos, so that each POC or demo or any tool in the industry can say, these are the categories that we are delivering, and this is our focus. So primarily we were looking at this table as being a tool that could be used with different POCs and demos to say, this is the intent that we are demoing, or this is the type of category that we are addressing. I hope that answers the question. Thank you.
Sure, thank you.
Okay, thank you. We have to close the comment now because we're already a bit over time. So thank you very much, Olga, for presenting. Jérôme, you have some word of conclusion on the call?
Yeah, as Olga asked for the adoption as an Nmrg draft. So my first question will be to know who in the room has read the document. Please raise your hand. Okay. Around 10 people. Okay. How many of you think this document is useful for the group? Okay. All right, same. Okay, great. And so many of you think this document is ready for Nmrg adoption? Okay. Yeah, so between 1 and 2, I would say. So maybe Olga will anyway send a formal call on the mailing list to have all the feedback from all the participants, as we say in the procedure. And then based on the feedback, we will be able to take a decision and discuss with you. So you can also review the different feedback you will have. So thank you again, Olga.
Okay,
and
thank you.
We move to the next speaker. I think it's Alex, right?
So I think this is easier. So good morning, everyone. I'm Alex Clem. I'm presenting a status update on the intent-based networking concepts and overview, draft version number revision 3. This work is also done on behalf of the co-authors, Laurent, Lisandro Granville, and Jeff Transura. So basically, since the last time, the draft has undergone one revision cycle. So we're now in revision 03. Basically, the updates are all pretty much of editorial nature. One thing, basically, there is a considerable section concerning the intent lifecycle, which had a number of diagrams, but relatively little text. So basically, these textual gaps have been filled in. The lifecycle has been described in much greater detail, including the various intent fulfillment and intent assurance functions, which are part of the life cycles and how they interact with each other. That was one update. The second update is there was a section on research challenges, which we felt was actually not appropriate for the scope of this draft, so this section has been removed. So this is just, again, the intent lifecycle diagram, which is actually, I think in the interest of time, we don't have to go through this. This has not really been updated. This has not changed, but basically this concerns the aspect of the document that has undergone a lot of textual revision. So this here is the document structure, so the updated document structure, compared to previously, you will see it's essentially the same structure, but minus the research challenges. In terms of open items and next steps for this document, so there are a few editorial updates that still need to be made. One thing is basically there are currently 2 diagrams on the intent lifecycle which need to be consolidated. That's one aspect. Second aspect is because a lot of the functions have been defined as part now of the life cycle, there's some textual alignment editorial alignment that has to occur between section 6, which talks about the life cycle, and section 7, which talks about the functions. You cannot really talk about the life cycle without talking about the functions. So there's some alignment that needs to take place there. The third question is basically listed currently as an issue whether or not to address this here. This concerns basically whether we need to distinguish between different categories and different intent granularity. The question is basically whether the document should talk about this at all, or if we just leave it to the intent classification document. And perhaps that is actually the appropriate answer. But anyway, this is basically one of the issues that is listed currently in the document. And then finally, basically, we want to update or we want to add a little bit on the security implications and challenges. So basically, the security considerations that are unique to intent, because that introduces new security issues. Okay, so in terms of also next step, we do believe actually that the document, well, this is basically where it fits within the Nmrg charter. So basically documenting the fundamental concepts, background and terminology. This is the main focus of this document. And accordingly, we wanted to actually also request, like the previous speakers, request adoption as an Nmrg work item, because we believe it supports directly our charter. Questions?
Hello. Yes. Hello, Diego Lopez. Yeah. I think that when it comes to the categories, precisely when you mention these categories and other, like, this is precisely one of the things that they still miss in the other document, in the classification. Precisely establishing those categories is what the classification is, in my view, and this is something that is not mature enough in the other one. I would leave it for the other one because it looks like the natural ways that we're making a classification, establishing the categories there. So we have here, well, not the problem, but the matter of synchronizing the other thing. And when it comes to the security implications, and think that is a great idea because it's something that is essential in the when talking about intent, and has been, this kind of long forgotten issue when talking about this. It's about, I'd say, express or whatever, but I think it deserves, not that it deserves some more attention about how is the security of the intent and how you express security requirements by intent precisely. And something that deserves more attention. Not that so far what I have seen in the draft is still in a very early stage, but I think it's a quite interesting path to follow.
Okay. Thank you. Yes, so we'll definitely, I think the implications need to be analyzed clearly. And regarding the classification, and one thing, the discussion we need to have, actually what we had in mind originally for this document, not the other one, was actually a much coarser level, right? Just distinguishing between the high-level operational content intent versus the intent for service instance versus the intent for flow, and just leave it at that. But anyway, thank you for your comments. Mm-hmm.
So if there is no other comments, I will go through the same question as before, as you call also for LG adoption. So who has read the document? Please raise your hand. Okay, 12. Who thinks this document is useful? Same. And who thinks this document is ready for the group adoption? Yes. Okay, 10. So as before, so this is the first feedback we get, and then we send the official call on the mailing list to have more feedback.
Right.
Okay.
Thanks.
Thank you, Alex. So next speaker, Luis, please, can you come?
Hello, everyone. So I will present the intent-based networking approach that we are following in the 5G project. So this is a tool basically developed by the people from WINS, which is a partner of the consortium. And I will present basically on behalf of them. So just for understanding what 5G is, the objectives of 5G is basically to set up a facility for 5G experimentation across Europe. So there are facilities in Spain, Greece, Italy, and France with interconnected data centers. And the idea is to offer abstractions to the vertical customers in order to deploy services, industrial services. The kind of vertical customers that we have in the project are utility companies like Electricité de France, or train companies like Trenitalia, or AGV systems as ASTIC. So different sectors from the industrial space. So showing briefly the architecture of 5G, what we have on the bottom part of the slide is these multi-site facilities with a number of tools for orchestration and programmability of the networks. We have OSM, we have ONAP, we have different kind of SDN controllers there. On top of that, the blue box that you can see there is the multi-site interworking framework, which basically tries to orchestrate the different sites for the deployment of the services. Just to mention that the services here in the context of 5G are basically experimentation, so are experiments to be run and to check the industrial case in every situation. And on top of that, we have a portal, and through this portal, the vertical customer can request the experimentation and can order the experimentation and the deployment in every of the sites. All the intent-based stuff is here in this box, green box, and I will explain basically what it consists now. So the purpose of intent-based in 5G is to provide a way for these vertical experimenters to instantiate an experiment. So the experiment design, the definition phase, and later on the trigger for being deployed in the sites. Through this intent base, what we basically do is to translate the request of the vertical to the vertical service blueprint. So basically, we fill a form for describing the experiment and passing through the orchestration framework. The final step is the creation of this experiment descriptor in such a way that, well, this service is deployed and the experiment is run. There are two choices at the time of declaring the service. One is the usage of a guided selection through a graphical user interface, so a kind of wizard. And the other one is the free text translation, where basically the request of the experiment or the vertical is interpreted and is translated for filling up that form. All the tool will be documented in deliverable 4.1 from this project that is expected to be released as public in the forthcoming months. So probably by the end of the year will be already public. Regarding the tool design, we have a graphical user interface that allows the experimenters to provide their intention. So they write down what is the objective of the test, of the experiment to be performed. There is a translation tool which basically takes that information from the vertical customer and translate and try to fill the vertical service blueprint for deploying the experiment at all. In case that some fields are missing, and so there is also a process of iterative interrogation in such a way that finally the system can fill all the details. Also, the tool consists of a database where all these experiments are stored, and also this database is used for checking if in the intended site to be deployed the service there are enough resources for deploying the service, and also to check the scheduling of the experiment. And basically a server where all this application is stored. You have here a link to the tool, so probably this tool also can be part of the tools, the repository that you were mentioning at the beginning. So digging into a bit the two different options that we have this free text format. So basically the experimenters might define their intention by using natural language. So they express the experiment that they want to perform. The way of expressing the experiment is basically the vertical customer requires to use some kind of keywords, or some keywords, let's say, and in some cases some special characters for identifying the specific field. For instance, some specific format for the time of the day, some specific format for the date to be run this experiment, also for signaling the number of instances and so. In case that there are empty files or files that cannot be completely filled after the intention of the vertical customer, the system is able to interrogate the vertical again for completing the information which is missing. And in case the vertical experimenter put some data that is not wrong at all, that is wrong or that is not good at all, the system is able as well to interrogate the vertical in order to fix what can be missing. Probably you cannot see from there, but there are here some examples of how this is happening. In any case, this will be documented in the deliverable that I mentioned before. The second way of requesting the service will be this guided selection, which is basically a kind of wizard where the vertical customer can go through different menus, let's say, and start filling the data for the experiment. If something is not filled, the system is able to provide default values, and at the end of the process, also the system interrogates the vertical customer to be sure that the parameters that will be part of the experiment are correct at all. So that was what we are doing in 5G. The next steps that we are considering is to generalize this concept to the processing of the GSMA or 3GPP slice templates. So in both GSMA and 3GPP, both are working in this network slice template. So the idea would be to take these ideas that we have developed in 5G, porting them to the request of services that would be expected from coming from 5G, from 3GPP, let's say for the 5G services for the network slices. And our intention is to document this in a draft targeting next IETF for reporting, having some report of how this has worked in reality in the different experiments, and also exploring this way of porting these ideas to 3GPP stuff. And that's all from my side. Do you have questions?
Any question on the presentation? So you mentioned that, okay, I see clearly a connection with the activity you want to do on the experimentation. I think this could be a good addition to the pool of demos. You mentioned that you would like to work on a draft.
Yes.
Have you already identified if it will be more towards the IETF or IETF, or and what will be the? It will be a kind of use case experimental type of draft, or more?
The idea would be to explore this. To take these ideas that we have explored in 5G, but port into the generic slice template and the network slice template from 3GPP. So, because what we have in 5G, these vertical service blueprints are not, does not match actually the generic slice templates and the network slice template. So the idea would be to take this from the experiments that we have done in 5G, but moving toward what could be a true slice request from 3GPP.
Okay, thank you.
Thank you.
Our next speaker will be Michel.
Good morning, everyone. My name is Michel Bonfim. I am a PhD candidate at Federal University of Pernambuco, and I'm here today to present a work that is part of my PhD thesis, and it consists of a solution for goal-oriented policy refinement in NFV manual systems. So let's start by defining policy refinement. This is the process of transforming high-level policy into directly enforceable low-level policy. However, policy refinement is a non-trivial process, and it remains a much neglected research area. And concerning NFV manual systems, this task is usually done manually, and the situation imposes the presence of a knowledge expert whenever this procedure is required. And besides, the scale of change can be massive, which can lead to improper specification of enforceable policies due to human errors. So we argue that this procedure must be done in an automatic way in order to reduce the gap between human intention and NFV manual behavior. So a fully automated refinement process in NFV manual systems, it is still an open issue. In this context, we tackle this problem, and we proposed the NS planner that is a goal-oriented policy refinement procedure for NFV manual systems. And basically, it combines the rich description logic expressivity with the efficiency of automated planner systems based on hierarchical task networks. So it uses a well-funded ATN planner to perform the goal-oriented policy refinement procedures, and it proposes the use of one ontology in OLL2 called the ontoplanner. This ontology will be responsible for store the current state of the world and, of course, the state constraints. So this figure shows the architecture of NS Planner, and we skip some parts and focus on the three main functionalities. And we will start talking about the functionality that is performed by this model, the goal-oriented policy management model. And this model enables one to describe, store, and maintain goal policies. And for this, we proposed this goal grammar this language grammar. And basically, summarizing, one goal applies for one or more virtual network functions of a specific network service. And of course, we can define one or more service attributes for this goal. And it is also possible to define the degree of importance of this goal as high, medium, or low. This figure illustrates how on-tom planner enable one to describe a goal policies, but I won't get deeper here in the interest of time, just to illustrate. The second functionality that I want to discuss with you is the policy refinement procedure, and that is performed by the planner generation module. And once a goal refinement request arrives to the system, this modeling work as follows. In the first step, it instantiates a copy of on-tom planner in a memory, and it extracts the current state of the domain and the requested goal information. All this information are stored in the on-tom planner. And then after that, it builds a planning problem document in Lisp code. I will talk about more later. And it uses this planning problem domain model and a previously defined planning domain as input for an ATN planner in order to perform the planning process that is basically the policy refinement. And once the planning process ends, it creates the enforceable policies using its outputs, and it stores these enforceable policies into the on-tom planner copy. Finally, it performs DL reason to provide inconsistency verification. This check is performed in order to detect if the state constraints are crossed, okay? And if there are no inconsistencies, the enforceable policies are extracted from the on-tom planner copy and returned to the user via API. Move on. This figure illustrates how the on-tom planner enable the creation of policies. They are basically event condition action rules, okay? And again, I won't get deeper in this context because we have a short time. And continuing, the last functionality that I want to discuss with you is the detection of policy conflicts, named policy analysis. And it's worth mentioning that policy analysis requirement for policy refinement systems. And to achieve its functionality, we created two SWRI rules, one to detect goal conflicts, and another to detect the echo rule, the enforceable policy conflicts. In this context, we can perform the detection of policy conflicts. The detection of policy conflicts is carried out through DL inconsistency verification when a reason is relied upon. So if there are inconsistencies, the DL reason will identify the errors and provide the possible explanations. So we developed an NS Planner prototype in Java, and basically it uses Spring Boot to implement the RESTful APIs and the OWL API in order to enable the on-tom planner management. And the conflict detection model uses the Hermit reasoner, a fully compliant OWL2 reasoner. And the planner management model uses the CHOP2, well-founded ATN planner that is maintained by University of Maryland. And of course, in order to validate the NS Planner, we implemented a use case that is basically a planning domain model for the resilience attribute. And this figure here show parts of the task decomposition of the resilience goal. And I'd like to highlight two sub-goals that are the failure prevented and the failure controlled. The former focus in setting redundancy and outscaling mechanism inside the NFV manual, and the latter, the failure is controlled, focus on setting some healing mechanisms. We also conducted a performance evaluation. I'm not getting deeper in the results, but summarizing NS Planner performance in scale as well as the ontology size grow. And these results enable to indicate the NS Planner as is appropriated to be used in a production environment as an auxiliary tool for NFV manual frameworks. And we believe that this work leverages two contributions to Nmrg. The first one, NS Planner enable goal-oriented policy refinement. In this context, NS Planner focus on intent-specific aspects, since goal policies describe desired states in our environment, not a sequence of actions. And finally, we believe that NS Planner provides a decomposition logic to resolve intents to relevant service and select appropriate management functions. And that's it. Does anyone have any questions?
Hello, Diego Lopez. A few questions. First one is when you show the resolution and the ontologies, do they apply to, to the initial planning, or are you making a resolution for some kind of service assurance?
I don't know if you understand, but
what I mean is that you do it once when you are planning with the man who is going to deploy the service, or you repeat it regularly for taking decisions on scaling out or things like that?
Oh, okay. Basically, the solution. This presentation is just a short view of the entire solution. So we have another mechanisms to perform this replanning once the solution detects that some policies are not working properly. And besides, this planning process generates some enforceable alarms that can detect any problem in the infrastructure, and of course it applies the corrective actions. But the replanning process is performed, but it's another part of the work.
Okay, great.
That's another contribution.
And just to be clear, when you talk about planning here, planning is?
Yes, planning is, we consider that the planning process is similar to the policy refinement. We consider that the policy refinement is a kind of planning problem. And here we use task decomposition. That is basically, we have a high-level goal, and you can decompose in how many tasks do you want. Basically, replanning means that you can verify if the policy are working properly, and if doesn't, you can replan, perform the...
And how you verify that the policy is not...
Yeah. I have another system that do this.
Okay, and are you going to present it today? No.
No, no.
Okay.
But if you want, we can discuss later.
No, definitely. And just a question, because I saw three inputs. I mean, you mentioned the operator and twice the orchestrator, two different modules.
Let me see.
But,
What is
no, but a little bit. That where? No, here. So you have the operator provides some thresholds. The NFV orchestrator provide the NS goals to this goal API and to the planner API.
Yeah. If I consider I might be details the entire work, I propose it, the operator can predefine alarms that will be created in the end of the planning process. Yeah. Okay.
Mm-hmm. Understood.
And we propose it extend an NFV orchestrated in order that we can define these goals inside the network service descriptor. And it will be responsible for extract these goals and then storing using the NS planner.
Okay, so basically each network service comes with a set of goals.
Yes, each goal applies just to one network service.
Okay,
you just need to define for each virtual network functions.
And in the planning, do you consider precisely the interaction among the different NS goals or not?
The interactions.
I mean,
do you mean?
If I have a network service that is saying has as a goal use as much bandwidth as possible, and there is another network service that has as a goal use half of the bandwidth available, for example, do you consider that they are requesting things that probably are conflicting, or?
Yeah, as I mentioned, I defined these rules where I can find conflicts between all goals that are stored, that are registered in the auto planner. And basically what I check here is if, let me see here, that's better. If there are at least two goals that applies to the same network servers and intersects with.
But that apply to the same network service, or that apply to the same magnitude in the network, because it's not the same.
It applies to the same network service, but okay. I want to detect here that I will don't have duplicating enforceable policies. For example, if I have a network service and I define two goals that include same virtual network functions, probably when I generate the final plan.
Don't worry, not to stop.
I think maybe Diego is mentioning more. If you have goals, conflict between different network services, not for.
Okay, no,
exactly. Two network services have conflicting goals.
I just check if two goals applying to the same network service.
So it's not. Let's say this is not multi-tenant yet.
Yeah.
Basically, okay.
Just very minor clarification question, because in your presentation you have some acronyms. Just to clarify, when you say DL, it's a description logic, not deep learning.
Yeah.
Okay. Yeah. And HTN, it's a hierarchical task. What's HTN? You have HTN in.
HTN is performant. HTN is the planning system.
No, HTN. In the task decomposition, I think. Go next.
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 Okay.
Next. See, the planner use SHOP2 as HTN.
Yes, I choose it to. We decided to work with an HTN planner. It's an automated planning system, where in which we can define a planning domain model and a planning problem, and these two models are using as input for this planner, and based on what you define there, it will generate a plan, a sequence of actions that you have to perform.
Okay, what does HTN mean?
HTN it's a kind of automated system planning. It is different from the classical planning. It is based in task decomposition that we believe that is better to work. It's more clear about how human thinks. So basically, and we need something that perform this kind of test decomposition, because we don't want to define just a sequence of actions and generate a plan based on their preconditions and effects. We want something that we can start from a high-level task and then generate just the actions that are.
Okay. I mean, there exists other paper in the literature for task decomposition and operationalization of policies. Have you also, do you have some related work?
Yeah, this work is currently under submission for the IEEE transaction networking. So I have a lot of material about it. If you want to know more about the related works and how the entire solution works, we can discuss later, no problem. But we have a lot of related works.
Okay, so I think this work is quite interesting for the topic of intent-based networking in the research group. I see that since you have already some implementation, it could also fit with the practical aspect, the tools. So I will encourage you to get in touch with the activity on this thing. And you can also come to us to know who to contact. My question is also from the more on the theoretical base, because you are proposing some techniques to address the goal decomposition, the planning phase. And I can see relationship with the life cycle, so the different steps that we have for the intent. We have also decomposition, we have conflict resolution. So I will also encourage you maybe to link with the author or on the mailing list, whatever. So because I think you can propose things to refine our understanding of the functionality, and maybe also propose some suitable techniques for being solutions to the different functionality.
Okay, I'm glad to contribute.
Yeah. Thank you.
Okay, thank you.
Next speaker, please. Sabine.
So, hello. So I'll start the presentation by a use case that motivated this work on over-the-top intent-based networking. And sorry, oh, come on. So is it better? Then a description of the framework we proposed, the first conclusion, and the challenges. So the initial use case was this demo that involved several Bell Labs facility, and this was about deploying slices for IoT and EMBB over a Cloud Run. So as you can see, you have already several types of clouds. So the problem was that to have it up and running, each time it was requiring like 1.5 to 2 hours of expert engineer and researcher configuration operation. So when we looked at existing research on intent-based networking for those type of use cases, we found out that, as it is written in several drafts, the current work at that time was focusing on policy, the service was connectivity, and there was that lack of languages to translate instruction from one system to another one. So what we proposed is to extend the intent-based networking from connectivity to applications, from network operation to over-the-top application provisioning, and from fixed network to more heterogeneous networks such as cellular. And the current focus on this work is to look at the intent request feasibility check. We are not this work is not about translating and natural language processing and stuff like that. And also the other focus is on intent network application slice automation. So this is the framework. So I tried, between the two versions I uploaded, I tried to play with some colors to map it with the work, the draft on intent-based concepts. So this, so the functions, this is the framework, the architecture framework for the intent-based, for the OTT intent, sorry. And this was already here. The only thing I did was adding the outlines. So we have already this space here. So in the draft, you have the, so this is why I took my paper, the user space here. And the functionality of the user space as indicated, they interact with the user. So this one takes in the application slice request. This one provides system feedback. And this is a key function in our vision, because this makes the difference between a GUI and intent stuff. It is this system feedback that the user gets. This is the history. ASI stands for application slice intent. So this stores like what happened, the name and things, whether it was interrupted, the status. And this is some dashboard that is exposed to the user, given that, of course, underneath the dashboard, you have more system, lower level computation. This is what is called this is the core IBM framework functions. So this function maps the intent request to a first level of what is called service graph. It's a graph of the main function that needs to be that needs to run to perform the service. So this is not yet talking about how many replicas and stuff like that. This is like a blueprint. So you have this initial graph, and upon this initial graph, before ever continuing, the first thing is that once you know what function you need to run your service, you should be able, and once you know, of course, what application you want to run, once you also know the population of your application, which means how many endpoints, for example, you should be able to provide a first level of dimensioning. So this is there's nothing new there. There's lots of literature and studies and online learning system, data-driven functionality to help you have a coarse-grained dimensioning. So before ever continuing, you have to check the resources availability, whether your infrastructure is able to deploy the necessary functions. So to do so, you go through this function, and this function is fed by other functionalities that compute the dimensioning and that compute it based on patterns, and where these patterns are based on system measurements. So this is like some classical loop. But we feel that it is very important for a reliable intent-based system to have already at this stage, this check. Because if this does not work, your intent will never be fulfilled, and you will, the risk is to run steps here unnecessarily, to lose time, whereas if you check this immediately, you just have a system feedback and say, for example, no, not enough resources or other reasons. This does not cover the no-go or the no-K from the system due to access right or policy, user policy. Okay, so once you have the OK regarding the resources, the system computes the deployment plan. So you know theoretically that you have several classes of servers on which you can deploy your functions, and this functionality computes the deployment plan. So this, I will not detail this work. This will be presented in December in GlobeCom. And then once this is finished, so the system generates the IBAS control commands, where IBAS stands for intent-based application slicing. So the system generates the commands. It can also progressively have several sets of commands that map to given sets of instruction. And then once it is ready, these commands are sent to this functionality, which is the IBAS control. This function and the other blue function belong to the network operation space. And in this framework, I also have outlined here the blocks in different colors, and this corresponds to intent fulfillment. So intent fulfillment is the block for intent fulfillment are surrounded by gray, and the functional blocks for intent assurance are surrounded with blue. So once the instructions are ready, they are sent to the IBAS control, and this entity is able to talk to all the management functions. So the intent framework here hands over the action and the commands to control functions. That's where the intent scope stops in the proposed view for OTT intents. And here you can see that you have something that is named leaf intent, because the one main implementation for SDN controller is ONOS, and you have this famous add ONOS intent, so which encapsulates quite complex computation for connectivity. But in our sense here for OTT, it can be considered as too technical, because somebody who requests, a customer who requests to deploy a slice for, I don't know, agriculture, has no clue of host name and port number and stuff like that. But the system here, at this level, this function is able to talk to other controllers. And this one function does have the skills to express an intent which is much more technical. And this technical intent can also seem very abstract to the southbound of a controller. So just the first conclusion of this framework is that we already have the complexity, although this is considered as a basic example, because you just have one request that is expressed on the northbound. 1 minute. Okay, so I will rush. So this is the proposed framework and how it fits to with the concepts and what we think should be added. So basically, control function that guarantee that you have the availability resources, and also at this level, verification and validation. And for example, so I'll skip this. This is how the intent is expressed using just parameters, a parametric model. So typically regarding the assurance, the validation is done here by just verifying the traffic. It can be done in two ways: verifying that the traffic is flowing and that the expected traffic pattern regarding growth, for example, scalability, is respected. Another way of validation or another assurance function is to verify that there is no problem with resources consumption. And so here, this is to validate the dimensioning rules that have been used. And the last function here is to verify.
Just make a pause. We are starting to run late again. I think Dan has a question.
What is emergence traffic?
Yeah, just a question.
Yeah.
Just a thing. So you ask your question, you answer quickly, and then I think you need to rush to the
conclusion.
Slide,
yes.
Okay. What is emergence traffic? If you go few slides back.
There was two types of.
One more slide back.
Yeah.
What is emergence traffic?
It's big bursts of traffic.
Emergency.
Oh, sorry. Yeah. Yeah. This is a typo. I'm sorry.
Okay.
Priority traffic.
Yeah. Okay. So this is another way of validating the system. I think there is a need for specifying validation functions at several levels, even looking at how long you take. So by the way, the setup time was like a couple of minutes. Even if this is very system specific, of course, this can be used again to verify that the slice has been correctly deployed. So matching this again against expected results. And this is something that was discussed in Montreal as well. This is something that is very useful, I think, in this intent framework and in the work that is being defined here, is define some targets and look at what happens and compare. Maybe adjusting the target, and then decide, should I adjust my system? Should I adjust my target? So the challenge is here is that, okay, this was a very basic example, although very complex because involving several classes of clouds and several functions. But this is basic. And we believe that in real life, the system, the deployments are much more complex. In real life, you have a constellation. You may have a constellation of such deployments. And there is a lot of work still to be done on what I just presented. But the big concern is what happens if I have several such systems interacting with themselves? What happens if, for example, I talk to several controllers, to 5 different implementation of controllers? So there's a lot of work that is needed to be able to send correctly my instruction to these controllers. How do I know that the controlling function I talked to has understood my request? And how do I expose, how can different systems expose a request that can be at some point, not immediately, but at some point understood by all systems? And you can look at the feedback slides if you like some more details. So I think I am done.
Okay, quick comments, please.
Well, first of all, I like the acronym. You know what ASI means in Spanish?
Sorry?
ASI. You know what ASI means in Spanish?
I see. Yeah, it's application slicing.
No, but I mean in Spanish. When you say ASI, it means this way.
Ah, okay.
So I like it. Just no, yeah, and now with the and another thing that I like is that you mentioned topology here because it's something that I have always believed is essential, and composition. That's two things that. Let me go to my notes. No, it's basically, if we have running out of time, just a question. You are defining as a slice the unit for intent, right? It's basically this, but you have not defined the slice. You just say, is the application slice intent? How do you define a slice in this environment?
Okay. The slice is the set of cloud and network resources that is allocated to run this this application. I mean, in this, it was very basic, and typically the slice was specified by the chain of functions and replicas that we use to run this application, and together with the budget of infrastructure resources.
Oh, okay, so it's computing plus network end-to-end.
Yes,
basically.
Connectivity plus application.
Okay, so I would not use the term OTT, but that's another story. That's
well, yeah, okay.
OTT sounds a little bit adversarial, but anyway, that's
yeah, maybe I may change the terminology. The point was that the tenant is supposed to be a customer.
Sure.
Requester,
no, exactly.
Yeah.
No,
Okay.
but probably normally we use the term vertical. So we were talking about verticals, and that's
Okay.
well, and the rest we'll keep talking about this.
Okay.
Dan Bogdanovic, you're mentioning slice, but I'm much more interested in the intent on the service topology than actually on the slice. I could have multiple different service topologies within a single slice.
Can you repeat?
So when I deploy a service, I'm creating a service topology. And I can have multiple service topology within a certain slice, because the slice is defining me the administrative domain, but the actual service will be defined, by the application on top of the service topology.
Yeah.
So I'm, viewing the slice just as an administrative domain, a set of resources that is given to an entity to have control over that.
I completely agree, and I see your point. This presentation completely skips the aspect of what I would call the definition set of the application, the definition set of the intent. That's yet another issue to tackle. But so in this presentation, yes, indeed, we only consider this is a very basic example, and on purpose, we started like a 0 point with no complexity regarding where do I deploy this, and as I said, the definition set, the topology abstraction, and what you can already request and have as constraint regarding the topology where the infrastructure when you want to deploy your service. That's yet another problem.
Okay.
Yeah.
Thank you. We have to switch to the next presentation. Benoit, please.
Thank you. All right, the pink cross. It will be difficult not to move, but okay. So what I want to present here, this is service assurance for intent-based networking. So where did it come from? At the last Montreal meeting, we spent like a day of Nmrg on intent, and I started to explain a couple of concepts there. In the end, I wrote the slide about it. The way we have to understand this is, okay, if we want we want to do service assurance as a way to do closed loop automation and maybe solve the intent later. That's the way you have to understand that. I presented those two drafts in OPS-WG already. So the issue that we have is that, okay, we configure a service as an operator, great, it's configured. It doesn't mean it works correctly. Then we're telling we could be sending all the telemetry, data lake, you do machine learning, etc. And we've got the issue of the needle in the haystack. What are we trying to do? Operators, they want to know when a service degrades, where is the fault? And it could be an easy one like interface is down, this is the root cause, but most of the time we need to have the symptom of what's happening and we need to do some more analysis. The second thing they would like to do is when a network component fails, which service are impacted? Typical data center issue of an ECMP issue, and we've got no clue what the services are, which one are impacted. So we know the end goal would be like self-driving, self-healing networks with the closed-loop automation. We could take a top-down approach, declarative way. It's a nice concept, but that works mainly for a greenfield deployment. In my world of operators, well, it's not that easy. So let's try to solve this differently by trying to decompose the issue of a service assurance into smaller components and trying to assure those smaller components one by one. Now, if we combine this approach with the end-to-end synthetic traffic test, then we have a complete view of the service. If we only take the synthetic traffic, then we have a kind of black box view of the network. We've got no clue where the issue is. And we need to drill down into the different components and assure them and to know where it is. So a couple of concepts in the draft. So the concept of the assurance graph, where we've got like a service, which is service instance, which is decomposed into subservices. Typically, for a very simple example here, a tunnel that depends on both source destination tunnel interfaces, that depends on physical interfaces, that depend on the respective devices, right? And same thing for connectivity. So if you could assure those subservice types, right, then we could infer the score, the health score of the service. And we could also report a series of symptoms up to the health of the service. Now for that, obviously, in an assurance graph, we have like two types of dependencies. The one that are impacting, well, if the device is down, obviously the interface is down, tunnel is down, and etc. If the interface is down, same thing. So these are the easy ones. What is more interesting is, maybe not more interesting, but the most applicable is informational dependencies, where in this example, I just put ECMP, right? So I've got the multiple paths in my ECMP group, and then one of them is badly behaving. Is my service impacted? Well, it depends is the answer. That's why we have this as informational dependencies. So what we know so far, if we know the assurance graph, and if we know the health of the different components in there, we know where the fault is, or at least to start with where it's not, because everything is healthy and green except a couple of points. We could start by investigating those components. We know also the symptoms or the root cause. Now, because I've got the three in one direction, I've got it also in the reverse direction, which is something interesting. I see this component in my network is failing or degrading, and I know the impact on all the services that are configured. Now, this is the architecture. Let me quickly go over it. We've got like a service configuration orchestrator. I made the difference between this one configuration and the one for assurance, which is the same orchestrator. So we extract the service, and this is for us a starting point for the intent. So we don't go from declarative, right? We try to extract it from the service. Now, from there, we did use the assurance graph, and we go in this architecture with some agents that are doing the mapping between the graph itself and the actual metrics that are current on the device or the devices. And that agent query, so it creates like a health status which is composed of the score itself of each component and the symptoms. And we send that via telemetry back to the configuration. That's where we could do closed loop automation if we know exactly which subcomponent is degrading. So if we don't do it by component, then we say, okay, the service is failing. What do? Do we reconfigure it? Well, not quite, right? There are situations in between, but this is the point. Now, this is a flexible architecture where both orchestrators, the one for assurance configuration, could obviously be the same box, and same thing for the agent, which could be in the box, in the router, or not. Now, it must be an open architecture, right? If we solve this one for a single vendor, great, but not many networks have a single vendor. And how do we do this? With a Yang module. Obviously, for me, a Yang module is an API, and we can augment this Yang module for multiple service types and for vendor-specific information. These are the two arrows in there in red where we open the API. We could read and configure the assurance tree, and also we could send my telemetry the score and the symptoms. What we're not doing here is trying to get the kind of standardized orchestrator, open source orchestrator, and also the expression that are used to say this is how we get the health of data plane is not in there. But this architecture should be open. So this is the full Yang module. I don't want you to look at it this way, but I want you to just read it through only what is in blue there. So even if you don't want to go into details of Yang, you want to understand that we are able to configure this tree and augment it, right, this assurance tree, with multiple service types, and that's the way to do it. You want to understand from the Yang module that we could get the health score and symptoms per subservice type and ID, and this is what we're going to push to the collector for the closed loop automation. You want to understand from the Yang module that you can create your own subservices with your own parameters. Obviously, a parameter is what is this? If I'm doing the health of this device, this is device ID. If I'm doing the health of an interface, this is that interface on that device ID. So the parameters will be different. And finally, you want to understand that we could augment this even with some vendor-specific subservices, which in the end will happen anyway. Even within a single vendor, we have different platforms, for example, coming back to the same example of the device health. And I think I've been fast enough as you wanted to provide discussion, which is more interesting. So this is the time to discuss this and get your feedback. I received quite some feedback already from operators in the Ops AWG. So up to you now for more feedback if you want.
I have a few questions as a participant. I will say that the assurance graph can be used. You can map it into our intent lifecycle in the phase of when you have service, when you have already decomposed your intent and you want to be able to monitor what corresponds to an intent, so to make the way up. So I think this could be we could use that as an example of a technique that can be used to fulfill a step of the life cycle. So I think it's a valid contribution in that sense. A question I will have is, where do you do the relationship with the intent? The input intent. Where would your proposal fit in a kind of intent architecture?
So I have to read the version of your draft. That for me, okay, my personal view, and then the answer to your question. I never like the term intent because it's fuzzy to me, at least when I speak to operators. Now, however, I take the beginning of an intent starting from the service definition, which I get from the orchestrator configuring the service. And most of the time, those services have a specific type. I want to do an L2 VPN, an L3 VPN. I want to do that VNF. And for that specific service type, then we could just deduce from the configuration of it the start of the intent. Make sense?
Thank you.
Just interrupt. I think there's a layer that's missed. It cannot be an intent around L3VPN. L3VPN is an implementation of intent. So again, there should be, to your question, layers that could consume intent as coming from the user and tell the way data model is built, look, I need you to implement particular intent as a L3VPN or EVPN or something like that, right? So
I would agree with that. Yeah.
Someone need to maintain all the bindings and actually expose northbound what intent is and normalizing down to the data model what it should be in terms of instantiation.
I agree. That's why I mentioned with the intent, it could be defined. It's a vague term, right? It could be defined from an end user, from the order, from the SLA, from this technology, or I don't even care the technology. So I would agree with that.
I wouldn't call it vague because you just build kind of bottom layer, and if you go bottom up, you could start building bindings given on set of technologies that are available towards definition of service, but in business terms, not L3VPN or VLAN terms.
I agree.
Alex, I think actually the dependency graph and those sort of things, I don't think is specific to intent. Clearly, basically, I think it's more widely applicable. But one question that I would have, I think I raised it the other day as well, is actually how do you maintain this dependency graph? I think this seems to be one of the key things that you basically, that you capture them. Do you basically establish them as part of the provisioning? Basically, you have basically additional operations there, or do you discover them, or how do you maintain them? And I think this will be one of the practical issues perhaps with this.
So it's both part of the configuration and both discovered. If I take, for example, if I rely on ECMP for a service, we're not going to configure ECMP part of the service, right? If we're depending on ISIS or SPF, we're not going to configure ISIS part of the service definition. Is done by a different group, right? So it's partly what you get from the service definition and what you get from the network, and yes, you have to maintain it.
Please, we are a bit over time. Thank you, Benoit, and for the comments and the presentation. But we would like to give also enough time for Dan to make his presentation. If you have further questions, please on the mailing list or after the session. Thank you.
Cool. Thanks. Okay, so 33.3% less time, approximately. Great. Okay, so dropping down a little bit from declarative / intent, looking at imperative policy. Now, this was a piece of work that was presented in NetMod earlier this week, so apologies if you attended that session. There's going to be some slight repetition here. But just wait for the final slide, and hopefully I'll try to put the discussion into the context of the Nmrg. So we don't really need to spend any time, I think, talking about ECA. You're all sort of highly aware of the applicability of ECA for applying policy to technology selection, service deployment, maybe resource usage. Just a reminder, actually, that for some of you, you may have been aware of a previous working group, SUPER, Simplified Use Policy Abstraction, which looked to sort of harmonize some of the imperative policy usage across various technologies in the IETF. Unfortunately, we never actually managed to publish a data model. We just couldn't constrain the problem space enough, even for ECA, and apply it. But we did actually have some success with publishing a framework. So there is an RFC that was published by the ISE. So as you're kind of discussing or continue to discuss intent, and I've looked at a couple of the documents that the Nmrg is working on now, you may also want to look at that super document. Although it does talk about sort of two information models. One is a general purpose information model. The other is an ECA-based information model. So going back to NetMod, essentially what we wanted to do with this document was treat it as a gravity well and pull some of the philosophical, some of the general discussion of ECA out of the data model solution work. So in terms of what are the use cases, how do you define the process, how do you manage a condition, an event, and an action, where do you store the state, what type of language might you apply, or how you would model the tree to actually implement the logic, how you handle notification, things like policy management, rule management, and policy resolution, especially in the case of conflict or competing rules. You know, all of these are actually quite important aspects and not necessarily discussion that you want to have in the solution documents themselves. So that's why we kind of put together this framework document. And you don't necessarily implement the framework, you just use it, you know, for your own maybe sort of vendor or operator specific implementation. So it doesn't necessarily give you an exact guide of how to implement ECA obviously into your network. The document also talks about some implementation considerations around operations and security. And I noticed that earlier today, security was kind of mentioned, I think, in Alex's document as an open issue, but it was also, it seems to be an open issue as well in terms of discussion in the intent classification document. So there may be some text that we could actually build on that's actually used in this document. Now, because we're kind of constrained on time for this presentation, I'm not going to go through all of these slides. What you could do offline is, if you're interested in this framework document, is kind of take a look at some of the questions that we're asking at the moment. So, you know, things like the preparation of ECA rules, scheduling, delegation, cataloging, how you manage state. Is it centralized? Is it distributed? Is it a combination of both? Yes, probably. Depends on the application. And you know, each of those actually represents almost another set of decision trees and sort of some fairly complex systems management. Again, things that you probably don't want to specifically describe in a solution document, i.e. the data models themselves. So this document may never be published actually in NetMod. It may have a time horizon of 6 months and then we just kind of close it down. It was just a way to kind of consolidate discussion rather than just flooding the mailing list. That may mean actually that we could use some of the text for ongoing work in the Nmrg, which I'll kind of get to in just a couple of moments. I think another big important area that will probably require further study is managing conflict when you're trying to apply policies. Now, Benoit's just kind of talked about sort of service assurance and applying almost kind of a hierarchy of ECA rules, you know, which could actually be, you know, if you think about recursive ECA, that in a sense is declarative intent. You're essentially starting at a high level, you're noticing a degradation of a particular service or application traffic, and then you're going to drop down through a hierarchy of ECA rules in order to identify a specific attribute potentially that's causing a problem, whether it's packet lost or just degradation of signal or application traffic. And there are going to be sort of, there's going to have to be some kind of control of sort of what you enable and when you enable it, and you obviously don't want to break your network as well. So all of these things are actually sort of really important. I mentioned that the document in NetMod also has some sort of implementation considerations, discussion text. So these are around operations and security. So here again, in terms of database management, so using ECA, how do you authorize it? You know, how do you manage who has access, or how you delegate a particular ECA to a device? Who's allowed to do that? When are they allowed to do that? What kind of method would you use in order to apply that policy? We also sort of highlight some database discussion as well, specifically the various states of data. So what are we looking for in the Nmrg currently? Well, not much really, just sort of highlighting that this particular document exists, and then it points to some of the solution work. Obviously, it's low level, it's imperative policy usage, but it may make a lot of sense actually to consider how this work, i.e., ECA, maps to intent. Your things like intent classification or service insurance. So documenting the relationship between some of the NetMod work and some of the discussion that we're having in this document to existing Nmrg discussion documents, although they are individual efforts at the moment, could be of interest. And also a piece of work that I'm working on currently under a UK project called NGCDI, which is Converged Digital Infrastructure. It's an EPSRC funded project, so not European-wide, just focused in the UK. We're actually looking at ECA implementations. We're establishing what kind of devices could we apply ECA against, and essentially a device isn't just a router or some kind of forwarding or functional element, but it's a limited controller in maybe in a very sort of specific technology domain comprising of a couple of nodes. And actually what we're doing there is also trying to identify what are the applicable languages, the rules, what is the current art, how widely deployed are they applicable for all types of ECA? Obviously not. So looking at network and resource and database management and just trying to classify them.
Great. Thanks, Dan, for being very concise. Questions to the presentation from Dan? Quick, Diego, yes.
Diego Lopez again. No, just a remark. I think I agree with, or I would say yes to most of the questions there, or to all of the questions. I think it's interesting. It's interesting, among other things, because I agree with them that this not everything is suitable for IETF activity, but
yes,
it's interesting here, especially because ECA probably is the best way we have to discuss about what I would call low-level intent or base intent or whatever we call it. In the previous presentations, we have been talking about precisely rule, conflict resolution, rule reasoning, etc., and reasoning about how this is translated and how different sources of intent and different tenants. This is something that would help, and would help as well to understand better what we are referring when we talk about intent. This is something interesting. So definitely yes, and if we can translate it into some kind of ECA framework document or something like that, I would happily support it and probably help with it.
Cool. Yeah.
Time
support's
permitting.
Great. Text is even better.
Yeah, and I think especially for question 2, this is something I indicated to Dan through some exchange that I think a good starting point could be positioning. We have a kind of proto-intent framework. You have your ECA framework proposal. I really think that there is a link between the two, where ECA is the kind of end of the chain application of an intent. Could be interesting to see how the two maps, if there are gaps, how they can interwork. So potential interesting questions to discuss. And again, if you translate into documents, even better for IETF or IETF.
Mm-hmm.
Thank you very much.
Cool.
We are at the end of the session time. Thank you very much for the presenters first, all the good questions and comments, especially for the 2 last presentations, since they were also linked to drafts that are being proposed in the IETF. I would propose that the authors can send a it's already been done partially, but send the draft to the Nmrg mailing list and ask for opinion from the group. A way to maintain some kind of relationship between these different bodies of work. I think it's an interesting proposal, and I really would like that it doesn't stop after this meeting. So maybe try to entertain some discussions. Thank you again. We have a session also tomorrow, last session of the meeting. So please join us. There will be discussion on use of artificial intelligence for network, and also some feedback on the side meeting and discussion on the charter. Thank you. See you tomorrow.
See you tomorrow. Thank you.
If you have not signed the blue sheets, they are here on the table. Don't forget to sign the blue sheets.